And then we imported the data. And then we scaled that data between 0 and 1. And then we split the data into 80% and 20%. So 80% to train on and 20% to test on. And then we created the training data. And we converted the training data to NumPy arrays. Then we reshaped it for the LSTM layer. Then we created the LSTM plus CNN model. And you can see it scrolls all the way over here, just in case. And then we compiled and fit the model. So this is where we trained it pretty much. We used the Atom optimizer. Then we created the LSTM plus CNN model. So this is where we combine them. And this is where we compiled it again. And then down here, that was pretty much the end. So this was the LSTM plus CNN model. I want to show you one more model real quick. And this is just the LSTM model. Actually, I want to show you two more models because I think it's nice to compare them all. So you can see we did the same imports. We loaded the data, pre-processed the data. We split the data into training and test sets. We defined the LSTM model. We trained the model. You can see it trained for 100 epochs. Then we made the predictions. And then we extracted the close price so we could do the MAE. Well, then we did the MAE. We got the MAE of 0.51. And then we got the R square. And then we got the MSE. So these are data points that we want to compare to our other models. And just really quickly, I want to do a overview of this ARIMA model now. So you can just depend on this one video to have like a ton of models, which is pretty awesome. See, we imported PD ARIMA, import pandas, we imported all this stuff, mean squared error, mean squared log. From math, we import square root. Model selection, we do grid search. Load the data. We get the closing price because that's what we'll predict on. We check for missing or infinity values. We remove missing or infinity values. We define the parameter grid search. And then we create an instance of the grid search. This took a while actually, but you can see all the code there. And then we fit the grid search. And then we printed out the best hyperparameters. We extracted the best model from the grid. We make the predictions. And then we calculate the MAE. Had some errors, calculate the R2, the MSE, and the RMSE. And then the last model that we just completed was the GRU, the gated recurrent unit. We imported NumPy, brought in the data, converted the data to a